But my question is, but remember, the issue of this project is not so much doing the project, but learning the collaboration.
All right, everyone, let's come back together and change gears a little bit. We're going to be talking about REACTO, which is the thing you are going to be doing every morning, at first gleefully, and then perhaps with increasing lethargy as senior phase goes on. I really shouldn't have this attitude. Everything is going to be great. Actually, I think REACTO is one of the most important things we do here, particularly in terms of getting you ready for the, I'm sorry again, I'm saying these words, job hunt. REACTO, you've seen the previous group of seniors doing it. It is a clicker that doesn't work? Damn. It is our whiteboarding practice session that we do every morning, and it's also an acronym for how to get through whiteboarding problems. Maybe I have the wrong one. Cool. So the schedule is this. Every morning at 9:30, we will, at the beginning of the week, a fellow is going to divide you into pairs, and each pair is going to switch off being the interviewer and interviewee each day. So one person will be interviewing Monday, Wednesday, Friday, or no, sorry, we don't do anything on Monday. So one person will be interviewing Tuesday and Thursday. The other person will be interviewing Wednesday and Friday. Interviewers will get the problem the night before to look it over. And then for 10 minutes at 9:30, the fellows will present to the interviewers. And then you will do your interviews for half an hour. And then the fellow will review. And we will be there to answer any of your more dire or pressing questions. Do you have any of those so far? That is dire, pressing questions. Okay, cool. So technical interviews, particularly the classic major tech company, aka Google technical interviews, often involve a whiteboard and writing code on it, which is not how most of us write code ever. So why is this? Torture, yeah. It's sort of a form of structured hazing. I'm not going to say that's not a part of it, right? That everyone's been through it, and so they think you should go through it too. We have kind of been using whiteboards a lot today, so it is something that's part of the practice. And there's also, if you don't code on whiteboards, there's a whole bunch of degrees of freedom. Now you need to figure out, okay, what environment do you give them? Do you give them an editor? Do you give them just a Chromebook? Do you let them use their own editor? If you do, how do you know what exactly they're accessing if they're doing it on their computer? Some tech companies, many of them are afraid of having you steal all their stuff, so they don't really want you bringing a personal device in there. So there's a bunch of questions. There's also a lot of good answers to most of them. So increasingly, companies don't just do whiteboarding for their interviews. There are also pairing interviews where you'll go in for half a day. Sometimes, very occasionally, it'll even be paid to pair with someone, and you'll work on an actual problem. Take-home coding challenges are more common, so it'll be something that takes you maybe a couple of days to do, and then you submit it. And then there's phone screens that are done over something like Google Docs. So there's increasingly many interview formats that don't involve whiteboarding, but it still happens a lot. And being able to code in this less than ideal environment is probably a good skill because it translates well to answering random technical challenging thought questions in other random hostile environments, such as you're going to encounter from now until forever. So REACTO is our training for that, and it's also an acronym that helps you remember the parts of solving a problem. So the first part of solving a problem is to, it's not gonna work, is to identify the problem. Might sound easy. It's surprisingly the part where teams often get tripped up. Try and remember this in Capstone when you're deep into some technical discussion, to ask yourselves and your teammates what problem you're trying to solve. Because surprisingly often, the answer will not be evident or the answer will be different for both of you, and then you've sort of identified where a disagreement might be happening if you're trying to solve for different things. Then you want to brainstorm solutions. You want to come up with various approaches. You want to do one of them. You want to decide if it worked. And that's it. If it didn't work, you go back to solutions and pick a different one. If you try several and none of them seem to be solving it, then maybe you are actually trying to solve the wrong problem. Like maybe there's a mismatch between here and here. So this is basically the pattern for solving anything, any problem you can imagine. And we've exploded it into this acronym for solving whiteboarding problems in particular. So the acronym, which thank God it's written up there because I never quite remember all of the letters, is to repeat the question. So the interviewer is going to ask you a question. It is probably not going to be completely described. So they're probably going to say something like, approximate pi using the Monte Carlo algorithm. And you'll be like, so what I heard you say was, and that begins a process of refinement where you say this and you can say like, okay, I don't know what these things mean. And your interviewer will probably be like, oh, okay, I can explain those things to you because you standing there not knowing what those things are is not what I'm trying to test today. So repeat the question and ideally characterize what you need to do in terms of writing a function. Not every whiteboarding problem you're going to get involves writing a function, but all of the ones for REACTO will. And so if you figure out, hey, I need to write a function that takes this data and returns this other data, and you characterize it down to what the data types the function is taking and returning are, then you've made the rest of your job much easier. In particular, you've made the next step, finding examples, a lot easier. Because let's say that the problem I give you is sort some numbers. So what is the function that I'm going to be writing? What is its signature? When I say signature, does that have like meaning? Kind of. What's the function signature? Someone who thinks I got it. Yeah.
It's just name and its parameters.
Yeah, so name and its parameters, and what about its parameters?
The order and length.
And there's a particular thing about them? Yeah, and their types. And then also the return type for the function. So and we don't think about this necessarily in JavaScript because you don't have to specify it in JavaScript, but you do have to know it. Like, I have to know that I'm going to receive an array of numbers, or like at least an array of things I can compare with greater than or less than, but let's say an array of numbers. And my sort function, let's say it's going to take an array of numbers and return an array of numbers. So that means that I can, if I write that and I'm like, okay, so you want me to write sort this array of numbers, returns an array of numbers. First of all, it gives the interviewer an opportunity to be like, no, I didn't mean that. I meant sort takes an array of numbers, returns nothing because you're going to sort them in place. You're going to mutate that array. So it gets you on the same page there. And second of all, it means that coming up with examples is really easy because anything that fits the type signature is an example. It's either an example of what you want the function to be doing, or it's an example of what you do not want the function to be doing. So if I get 5, 3, 4, 1, 2, and return 1, 2, 3, 4, 5, good example. Taking that and returning anything else, example of incorrect behavior. So you'll come up with a couple of both, or with a few of both. Mostly, you'll come up with examples of what you want your function to do. So for example, and like, think about edge cases here, where you'll want to, I'm realizing that there's a future slide for this, so I'm gonna cut this short, but you'll want to focus on like what do I do with an empty array? What do I do when I'm given data that doesn't fit the expectations that I have? Okay, so given some examples, you'll come up with an approach. You'll think, okay, I can use this algorithm that I know of, or I think I can apply this algorithm if I do these things to the data first. You write some code. You test your code, usually by walking through one of the examples you came up with. And then you ask, could I have written this any better? So something to observe is that code is like pretty far down here. A lot of the time in a technical interview is going to be spent working on getting the parameters right so that when you write the code, you don't have to change too much about the setup or your understanding of the problem. Because that can be very hard once you're in code mode to switch over to a different mental model. So I'm going to bomb through these slides because I started talking about them. Repeat. Do the thing with the interviewer. Get on the same page. Come up with edge cases. Come up with representative cases. So for sorting an array, sort an array of numbers, like pick a small array. Pick, in particular, something small enough that you can go through it on a whiteboard because you're not going to have a computer handy. When you talk about approach, we're talking about a higher level description of your approach than coding. So you might say, I'm going to find the largest number in this array, and then I'm going to remove it, and then I'm going to sort the rest of the array. So I've sort of described this, I think, bad recursive algorithm for sorting an array, but I haven't gone as deep as actually writing out the loops that are needed to make that happen. Finally, when you code, these are the most important things. Write small, I'm serious, write legibly in the corner of your board. I like to do all of my planning on one side and leave half a board for writing the code. If I know that the interview is going to go towards me writing code, which it usually does. Also, try and stay out of the weeds for as long as possible. So the thing I like to do this is I like to, if there's some operation that I need to do, like say find the largest number in an array, I might just assume that a function exists that does that for me. So I'll say, okay, I'm going to call the maxFrom function, which I can write later if you need me to. So this does two things. It keeps my code cleaner because I've already sort of factored out what would be a sort of, long for a whiteboard for loop into a different function. Two, I might not have to write that function ever because the interviewer might be like, you can write that. You've written something of equal complexity already. So I've just saved myself time when I would have been tripping over myself to write a for loop on the whiteboard. And it sort of demonstrates good coding practice from the get-go, where you're already separating things out into components. So finally, when you test, go through the examples that you declared earlier and sort of walk through one of them. And be as fine-grained as possible. It's very possible and even likely that when you're walking through an example, if your code is wrong, you don't think your code is wrong. So anytime you're inclined to hand wave over oh, and then this part obviously produces the right answer, you might be leading yourself into a trap, or rather falling into the same trap that you fell into when you wrote the code. So actually take the time to pretend that you are as dumb as the JavaScript interpreter, and if there were such a thing, and go through the code line by line and sort of follow what's going to happen. And then finally, we're going to talk more tomorrow about Big O. You probably touched on it a little in sorting and earlier workshops, but get a sense of how your algorithm is going to scale. So what is its Big O in time and space? And this is one of the hardest intuitive things to pick up, but can you do better? And one of the reasons we do this REACTO practice is that only after repeated exposure to a lot of different problems and a lot of different solutions will you start to kind of intuitively feel oh, this is looking at this quality of a list of numbers. I'm pretty sure I can do that in n log n time because I think that sorting it will make my life easier somehow. Excuse me. But at a minimum, you can look at the answer you've gotten and say okay, this is n squared. How's that? And the interviewer can be like, I wanted no offense, sorry. And that's fine. Like, that doesn't mean you failed. The interviewer is actually always going to push you to a point where you can't do anything, where you're like, I really am not making useful progress on this. Because that's how they know, like, that's how they know the top, right? The interviewer has had, like, an arbitrarily large amount of time to study a problem. So they should, in fact, know it to a good enough depth that they can stump anyone. And they're trying to get you to stumped. So it's not a bad thing when that happens. That won't necessarily happen in reactos, of course. These are shorter. So final thoughts. You want to think of the interviewer as a collaborator through this process. That's easier to do when they're your classmates and harder to do when it is an interviewer at some company that holds the keys to your entire future in their hand. Which is not true, incidentally, but is definitely how it feels. But nevertheless, if you think of them as a collaborator, you will, and like are actually able to convince your body of that, then they will pick up on that and start to even subconsciously think of you that way, which is what you want, right? Because you want them to subconsciously think of you as a coworker or as a future coworker, so that they'll like put that in their interview feedback. Like, yeah, I think she'd do well on this team. All right. Any questions? Yeah.
So a couple of things you mentioned, a couple of issues that I'm worried about. Number one, you really start in the top left. What about for the people, some of us who are shorter? Like, I can't reach top left and have the whiteboard in the room.
So one thing you can do is ask to write on paper. Like, if like you're more comfortable writing on something that is not a whiteboard, like anyone should let you do that. You can also lower some of these whiteboards in like a very practical sense. Those are the two ideas that I can think of. Gabe?
Yeah, and I was just gonna say also, it's not all about vertical, it's also horizontal. It's like if you know you are gonna want more horizontal space, you can cordon that off and say, can I use, this landscape area?
Yeah. Yeah, and the interviewer...
Very common, sorry.
Oh, sorry. In like an actual interview, they should definitely work with you on like making sure it's supposed to be a little uncomfortable, but not for those reasons.
And my second question is, how much will they deal with bad handwriting?
Not that big a deal. Honestly, most programmers have like... I'll say a lot of programmers have miserable handwriting, but... legible is better than illegible. They're also taking notes while you're doing it, so they can sort of be writing down like things and like making note of what you're doing. So it's not as big a deal. Like they'll take a picture of the whiteboard afterwards usually, and that's usually just to jog their memory of how things went.
So what happens if you let go and then you just can't figure out an approach to the problem? You just stand there and be like,
You never give up. You never give up. Yeah. I cannot cancel that you should just walk out of an interview now.
Like, could you ever get a job if you can't solve an algo? Is that like
yeah, definitely. Like, if you, because you'll have like, I mean, if you can't solve even one, no, probably not there at least. But like, but you'll usually have like a coding challenge and like talking to people interviews and a couple of whiteboarding interviews. And if one of them is just like a disaster, that's like, it's still possible for you to like do fine in the interview process overall.
And a lot of interviewers will have more than one problem ready to go.
Yeah.
And it's like if they feel like it's just not productive to do that problem, they'll maybe sometimes switch tacks and try something completely different. And that's another opportunity to show it's like, yes, I do know what I'm doing. I understand vanilla JavaScript. And that could be like, oh, okay, so later they write it down. It's like, well, they clearly didn't know where I was going with problem A, but they did really well in problem B, and we compared that to all of our other candidates. It's like, yeah, I mean, that the in-person interview didn't go great, but it wasn't like a complete disaster, and the rest of this, application is good. And when we look at our applicant pool, we think this is somebody who could succeed and could keep learning and growing.
As an starts off with an approach and like you see a hole in it, like
Mhm.
do you tell them or do you let them like continue down that path for like 10 minutes until they figure it out?
I usually let
Can you
them.
repeat that?
Oh, sorry. So the question is, as an interviewer, if you see someone starting down an approach that has a problem, do you tell them about it like immediately? Do you let them sort of get into the weeds and then tell them about it? Basically, when do you stop them? And my answer would be usually like after someone comes up with an approach, they're usually pausing periodically. So at some good moment, relatively early, I'll ask a question that should lead them to discover that problem. And maybe if it depends on the intensity of the rabbit hole, right? Like if it's a really bad knot that they're just going to get tied up in, and I don't think it's useful, I'll start to be like, maybe we should consider another approach after like maybe 5 minutes of them like starting to get tied up in it. Or like, what if we stored things this way rather than this way? Because watching someone be in the weeds for 20 minutes is just not fun for anyone.
Yeah, I personally, sometimes I have to fight the urge because I spend all day teaching. Sometimes I have to fight the urge to immediately say like, but if you did that, think about what would happen 5 steps down the road. Because often people are capable of coming up with that themselves if they just had another 60 seconds to try it out and think about it. So I think that you should always sort of quell the first initial instinct to tell them or help or lead them to what the conclusion of their thought is. Let them try it for a short period, but it really is a short period. And if they just keep on confidently forging in that direction and it doesn't seem like it's actually going to yield dividends, then you can start to guide them back with hints and saying things like, so I see where you're going with this, but what happens if X? And see if they can like follow the logic to that themselves. And then eventually at some point, if they're just like stuck on the path, they could be like, we could keep going on with this. I think that would take a little bit too much time, and I want to show you something else, a different approach. So what about if you took this other strategy? Where that actual threshold happens in terms of timing and how they express their confidence, I think is something that you have to pick up with practice a certain amount. There's no magic bullet.
And like, is that what we can expect like in actual interviews, or like will they just let us like flail?
They shouldn't let you flail for that long. I mean, if like you've been flailing for 20 minutes, that's the interview from hell, and I would just start saying like Bloom filter, hash table, just like start saying data structures until you get the job.
Blockchain.
What's that?
Blockchain.
Yeah. Oh, well, no, that'll get you funding, which is fine.
Another thing is that every interviewer is different. They all have different styles. I've known ones that I had a friend who's a PhD and he goes into interview at this place and they give him a question, which we talk about later. And he says he got to the answer and he wrote out this answer and this explanation and the diagram. And he's like, it's amazing. Like, I think this is it. I don't think it could get better than this. And he's like, can you? And the interviewer's like, I don't know. And it's like, do you really not know? Or are you telling me that because you just don't want to give me a hint? And then I've known interviewers who are much more collaborative and they want you to see various things and they're seeing if you can kind of pick up stuff over time. So it really depends on individual interviewers' personalities as well. And that, honestly, to some extent, can factor into, the interview isn't one way. It's not just them interviewing you to see if you are good enough, quote unquote, for their company. It's also you interviewing them to see, like, what kind of people work at this company? How do they do things? How do they work together on a problem? And is this the kind of experience that I want to go to? Maybe I like this kind of challenge. Maybe I think that it's showing that they only accept people who can kind of pass through the eye of the needle. Maybe I'm very different from them, and I feel like, I don't want to go to a place where they treat everything like a competition. So, it takes all kinds. Aaron?
How much of this should be pure like language, and can we like pull from a framework that we may know? Like, for example, if I know something in Lodash that may fix my particular challenging
my
them.
stock answer to the question of should I implement it myself or use a tool is you should always say something along the lines of, if I were coding this for an actual production app, I would use this tool. If you want, I could show you how to implement it. And then they might say, no, it's fine. Underscore clone, you can use that. I don't want to see how you test edge cases in clone today. Or they might say, yeah, let's do that. I don't want you to rely on this magic. I want to make sure you understand how it works. So you give them the option of kind of directing that, demonstrating that you feel confident enough that you can go either way. If you do feel confident. We're going to do a little simulation.
Can you give me the microphone?
Oh yeah, sorry.
Sorry, I didn't realize you were switching.
Sure.
Thank you.
We're kind of switching. So we're now going to do a demo. Gabe is going to be the sacrificial lamb, the first reacto of the senior phase. Okay, well, hi, welcome back, New Corporation. There's no small talk here.
Yeah.
What do you know about happy numbers?
Happy numbers.
Yeah.
You know what? There's actually a Doctor Who episode where he quoted what happy numbers are, but I've forgotten since then.
Okay, so we can talk about them. I will tell you what a happy number is. So a happy number is a number that when you keep tickling it, it eventually becomes 1. That is, it finds its center and its grounding and
Satisfying.
nirvana. Yeah, it's satisfied. So what does it mean to tickle a number? So tickling a number is when you break it into its digits, base 10, and you square each of its digits, and you find the sum.
So tickling, if I can recall what you just said, is when you break the number into its constituent digits.
Yep.
And then what do you do with the digits?
You square the digits.
Square all of them.
Yeah.
And
then you find the sum of the squares of its digits.
okay,
So
so
that's what the tickle function does. Yeah.
2, D1, etc. Okay, so for code purposes, what I'm reading is that I haven't heard the question yet.
Oh yeah, so the question is going to be write a function that tells you if a number is happy.
Got it.
So specifically, a number is happy if it becomes 1. It is unhappy if it enters into a cycle and never recovers.
Ooh, okay,
So
tricky.
some numbers, unhappy ones, will just loop forever.
So I wonder, maybe you can tell me, maybe not. Do all unhappy numbers enter a cycle, or do some unhappy numbers stop at something other than 1?
They all enter into a cycle. That's the definition of an unhappy number.
Okay,
There's no stopping point other than 1
interesting.
in the
Okay.
happiness sequence.
That's cool, and from a mathematical perspective.
Yeah.
So from a code perspective, what I'm hearing is something like is happy, takes in a number, and it returns a Boolean,
Yeah.
true or false, depending
Sounds
on whether
good.
it's happy. Okay. Yeah, interesting. So ways that I can tell. Well, clearly, I think it's going to be relatively easy to tell if a number is happy, because all I have to do is apply this algorithm and check if the result is 1. The algorithm being split into digits. I'm pretty sure I can do that by stringifying the number.
So to be clear, a happy number, you tickle it repeatedly, it will eventually become 1.
Right.
But
so
the first tickling might not be 1.
Got it. Okay,
Yeah.
that's good. So I'm going to do this in some sort of loop. I'm going
Yeah,
to constantly tickle the result. It's going to feed back into itself.
exactly. So you tickle a number, that returns a number, then you tickle that number.
Got it. Now I understand much better why it's either 1 or a cycle, because we're going to just keep cycling forever until it maybe becomes 1. Figuring out if it is 1, I can see how I can in finite time come up with that just by applying this process over and over. And if at any time I result in 1, I can return true. I want to think about for a second the idea of detecting that it's in an infinite cycle. I guess to detect if it's in an infinite cycle, I'm going to have to